Dear all, welcome to today's lecture on the different softwares that are used for CAD, CAM, Computer-Aided Engineering (CAE) and Computer-Aided Process Planning. So we will see which are the major softwares that are used in the industry for each of these sectors. The software or the softwares that are mainly used for CAD purposes are called as application packages, where we install this software into our laptop or desktop computer. And the computer also has an operating system already installed in it, like Windows. Different versions of Windows are there, then Linux. So different operating systems are there, but most of the CAD softwares support only in Windows. Linux versions are also there, but Windows versions are most popular in CAD softwares. So we have the operating system, which is a software, and also the application package or CAD software that is installed in an operating system. Now these are the different CAD technologies or computer-aided technologies which you come across frequently. You might have heard some of these names: CAD, computer-aided design, computer-aided manufacturing, computer-aided engineering, computer-aided process planning, computer-aided quality assurance, computer-aided process planning and scheduling, and computer-aided storage and transfer. So these are some of the methods which use computer aid for performing these operations. Now let us look at which are the major softwares that are used in the industry for all these purposes. So first of all, let us look into the modeling software. So there are mainly two different types of softwares used or software packages used. One is for modeling and the other is for analysis. Modeling means we are creating a 2D or a three-dimensional geometry or three-dimensional model of the object in that software. And analysis means we perform different types of engineering analysis on the already created two-dimensional or three-dimensional model. So the popular modeling softwares used in the industry are Solid Edge, SolidWorks, CATIA, Drawing, Autodesk Inventor, and AutoCAD. And the most popularly used analysis softwares are ANSYS, NASTRAN, and ABAQUS. Many other different softwares are also available in the market, which are open source tools. Open source in the sense the program code used to develop these softwares are available free of cost, and they are available for editing. So anyone can download these softwares and can access the source code or the program code of the softwares and make changes according to their wish. So such softwares are called as open source softwares. But these softwares are actually licensed softwares. So licensed softwares means the license or the right to sell or to change any or to make any modifications to these softwares can be done only by the corresponding company which is manufacturing that software. For example, Solid Edge is a software that is created by Siemens company. So Siemens company alone has the license to sell the Solid Edge software, and can also only Siemens can make necessary changes in the software coding or program in which the solid edge is made. Similarly, other softwares which are listed here, all these are licensed softwares. Each of these softwares come as a user license. For example, when we purchase solid edge, it will come as a 50 user license or 30 user license like that. So only that many number of users can use that particular software at that point of time. If we purchase a 30 user license and if the 31st user tries to use the software, then it will show an error, it will not open. So all the softwares come as a definite number of user license, 10 or 20 or 50 license or 100 license. So depending on the number of user licenses, the cost will also increase. So that is the licensed softwares. Again, we have analysis softwares like ANSYS, NASTRAN and ABAQUS, which are also licensed versions. So similar to these softwares, both the analysis, the modeling softwares and the analysis softwares, there are many softwares that are available which are freely downloadable and which are open source softwares. If you can search the internet, you can find a lot of similar softwares which are open source softwares. We can freely download them and use them. But in the industry, licensed softwares are more important or given more importance because of the many features that they provide. So each of these softwares, they give a lot of additional capacities for modeling and analysis to the user, and therefore they are very popular in the industry. Most popularly used softwares, we can say SolidWorks is one, CATIA, then we have Pro-E, which is again replaced nowadays. The name has changed to, you may know the name, Creo. So Pro-E, the name has changed into Creo. So Creo has become very popular nowadays. We also have AutoCAD, which is very popular, and Inventor is again also very popular. Solid edge also, to an extent, it is widely used in some category of industries. And regarding analysis softwares, we have ANSYS, which is the most popular analysis software, followed by NASTRAN, and we also have software or software package under HyperWorks. So HyperWorks is actually a software package which includes a number of different softwares for different uses. And one such software under the HyperWorks package is HyperMesh. So HyperMesh is actually a software which has very good functionality of creating meshes. So meshing, we mentioned what is meshing. When we have an object, we can divide it into different smaller elements, and then we can do analysis on each of these smaller elements. And these elements are called as mesh. So meshing is a process before conducting an analysis, and how we mesh this object, it will determine the final result of the analysis. So if we are meshing it properly, we will get a good result. Okay. So HyperMesh is a software which can do meshing very efficiently. So these are the software packages and overview of the software packages that are used in the industry. So let us look into which are the modeling softwares that are being used currently. First, Solid Edge. So this is the software which we have currently installed in our computer lab, and you'll be learning about this software, or you'll be doing some practical exercises in this software in our lab. Solid Edge is manufactured by the company Siemens. and it is a three-dimensional modeling software. It means we can create three-dimensional model. So how can we create a three-dimensional model? First we draw a two-dimensional sketch, and then we go to the three-dimensional workbench or the workspace to convert this two-dimensional figure into a three-dimensional geometry by using certain options. Options, or we can say features. So the features which we can give are, if we want to create a solid projection or a solid object, then we can do extrusion. Extrusion is a common name, so for different softwares it will be different. So extrusion means you will be creating a solid object in three dimensions. You will be adding solids. Similarly, you can create a hole, or you can even delete or remove the three-dimensional solid from certain areas, and again you can create different three-dimensional areas using certain figures. So all those features are possible. So three-dimensional modeling is actually starts from two-dimensional figures. So you create a 2D geometry first, or 2D sketch first, and then you convert the two-dimensional geometry into a three-dimensional geometry. And it utilizes a parametric feature-based approach. So features, as we mentioned, features are those options which we use to create a three-dimensional model. Like extrusion is there, then you can create a hole, you can create screw threads. So all those features, all those options, we call it as a feature. The options which we perform on a three-dimensional geometry is known as feature. And parametric. So what does parametric mean? So parametric feature-based approach means that when we create a two-dimensional geometry and then we convert that to a three-dimensional model, suppose we have to change the geometry of this model. So what we have to do? So we have to again change or make corresponding changes in this two-dimensional sketch which we have drawn, and this changes will be automatically reflected in the three-dimensional figure. So whatever changes we make in two-dimensional sketch or two-dimensional figure, once we have already made the three-dimensional model, it is possible that if we make any changes in two-dimensional figure, it will automatically reflect in three-dimensional figure. Otherwise it is very difficult. Suppose we have to change the length, or width of this rectangle on the three-dimensional geometry. Then if this feature was not there, again we have to create another rectangle of desired dimension, and again we have to make or create that geometry in three-dimensional geometry. That is very time consuming. But instead of that, they have introduced a parametric feature-based approach, which means once you make any change, once you create a three-dimensional geometry, and if you want any changes in the dimensions in this three-dimensional geometry that is created, you can easily access or take the sketch of that 3D model in 2D, make changes in this 2D geometry, and finalize it so that automatically those changes will be reflected in the three-dimensional model. So you don't have to do anything addition, you just have to change the two-dimensional sketch. So automatically the change will happen here also. That is known as parametric feature-based approach. So most of the three-dimensional modeling softwares use this approach because it is very easy to model. It is a Windows-based system. So as I mentioned, 90% of the modeling softwares are based on Windows. So Linux and Mac OS usually does not support any CAD modeling softwares. Linux supports very few. Mac OS, which is used in Apple products, Apple iPod, or you can say the laptops or the desktops that Apple makes. So the OS used in that is Macintosh or Mac OS. So Mac OS does not support the CAD softwares. So it is a Windows based system and it is a direct competitor for SolidWorks software. So SolidWorks is another software, three-dimensional modeling software that is very popular. Solid Edge is a competitor for SolidWorks. So both are made by different companies. And Solid Edge has part modeling. Part modeling means you can create different parts. Once you draw a two-dimensional figure or two-dimensional sketch, you convert it into three-dimensional geometry or three-dimensional model. So this model, we call it as a part, a solid part. So if you have to create an assembly using a number of parts, what you do is you create a number of or the different parts individually. Suppose there are 4 parts which make up an assembly. You create each of the parts individually as a different files, and then you bring all these files into a single place known as the assembly workbench. You have the assembly workbench. So workbench is a place where, or the area where you work. So assembly workbench, you open assembly workbench and you open all these individual part files and export into this. So you have different parts in that workbench. Then what you do is you try to perform assembly of all these parts. All these parts can be moved with relative to each other, and finally you will be doing the assembly. Okay. So such features are available in SolidWorks. Now coming to the second most popular software, that is SolidWorks. So SolidWorks is actually a software that is very popularly used in the industry, most of the industries, and developed by Dassault Systems Corporation. Not developed, actually SolidWorks was founded in 1993 by an MIT graduate, John Hirschtick. So John Hirschtick actually founded SolidWorks Corporation. SolidWorks was founded as SolidWorks Corporation as a different company. So SolidWorks Corporation made a number of different versions of SolidWorks and was very successful, and later on Dassault Systems company, they acquired SolidWorks. So Dassault Systems was entirely a different company, and as I mentioned, it is a French company which manufactures Concorde aircrafts. So Concorde aircrafts are supersonic aircrafts. They were manufactured by Dassault Systems, and they procured or they acquired SolidWorks Corporation, and therefore then on SolidWorks became software of Dassault Systems. Okay. And Dassault Systems also developed another software which is very popular in the industry. We'll learn about that also, that is CATIA. So CATIA was the original product of Dassault Systems, whereas SolidWorks was actually made by an MIT graduate, John Hirschtick. He founded the SolidWorks Corporation, and later on Dassault Systems acquired SolidWorks Corporation. So it is a 3D modeling CAD software used very heavily for mechanical engineering and design industries. A lot of applications are there in SolidWorks. And again, similar to Solid Edge, it also has the same feature, parametric feature based approach. The parameters can either be numeric parameters. So the parameters like line length or geometric parameters such as tangent. So we mentioned the parameters are as the different features that are available in the software. And features are the building blocks of the part. Building blocks in the sense how we create the three-dimensional model. As I mentioned, we have extrude command, or we have the remove command. So a lot of commands are there, and those options we call it as the building blocks or features, because we create the three-dimensional model using all those features. And drawings can be created from parts or assemblies. That is an option which I already mentioned. So such softwares, once we create a three-dimensional model or an assembly means it will have a number of parts that is assembled. So once we have created the three-dimensional model, there is an option to automatically convert this into an engineering drawing. So you just have to give that option, and the software will automatically create a drawing sheet with a title block, the scales, and then the projection type, which angle projection is used, and all those things, and it will create the different views of this part on the drawing sheet. So all these things are conducted automatically. So that is the option which is given to most of the CAD softwares. They can be created, drawings can be created automatically from parts or the assemblies. Then let us look at what are the features of SolidWorks. We have product design simulation. So how you are doing the design process, the entire process can be simulated. Solid modeling option is there. You can create 3D models. Product data management. Data management means everything that is related to the product formation. So right from the beginning to the end, how you are going to manage the data related to the product designing and assembling and manufacturing. So all those data can be managed in the software. Cost estimation, manufacturability checks. So what are the cost that is occurring or incurring for the different parts? Raw material cost, then transportation cost. Then during manufacturing, are there any quality issues, whether manufacturing is going as per schedule? All those things can be done or checked using SolidWorks software. Then created with the ease of use in mind. So it is very easy for a user to create a part using SolidWorks, a 3D model using SolidWorks. So when you use that software, you will find it very easy to use. So that is why the user interaction is given most importance in SolidWorks, and used by mechanical and electrical engineering department. Not just mechanical and electrical, a lot of other industries also use SolidWorks as a design software. Which type of industries use SolidWorks? We have aerospace, aviation, customer products, manufacturing, medical devices, industrial products, oil and gas industry. In oil and gas, what we do is we do the designing of pipes and carriers of oil, how the gas is being transported. So mainly deals with the piping design, oil and gas industry, piping, rig design, etc. So almost we can see all types of industries make use of SolidWorks software. So it is a very popular software. And we have different versions that are available from the starting to the ending date. I think the latest version is SolidWorks 2021. So every time when we have a new software that is released, it is called a version. For example, suppose in the year 1950, SolidWorks, suppose we have in the year 2001, you release the SolidWorks 2001 plus, and if you have certain additions or certain features that are added later on, for example, in the mid of 2001, more features are added to the SolidWorks software, then we call it as a release. So that is a difference between version and release. So a release actually means few additions that are made to the software package, and when a lot of additions are made and the software changes entirely, then we call it as the version. So we may say version 1 release 1, then version 1 release 2, version 1 release 3, and so on. So after some releases, for example 5 or 6 releases, we have some major changes that is happening in the software. Then after that, the next release we won't be giving a release, then we will move on to version 2, release 1, version 2, release 2, and so on. So after a number of releases, a major change has happened in that software, we change the version. So that is the difference. Then the most popularly used another type of modeling software is CATIA, that is computer aided 3-dimensional interactive application. Again, CATIA was developed by Dassault Systems. So this is the logo of Dassault Systems, DSS, actually they have mentioned it like this, DSS. And CATIA is mostly used for surface modeling. You can create 3D models also, but surface modeling is most important, or CATIA is given or prioritizes mostly on surface modeling. So what is a surface model? You create any shape, for example you draw a spline, then you can create a surface with that feature or spline. So surfaces, as we studied in surface modeling, it will not have any thickness, it will just have a small volume, a surface area, not volume, surface area. So this type of shapes we call it as surfaces. So when are surfaces created? So surfaces are created usually when we have to do certain modeling on aerodynamic surfaces, or when we have to create an aerodynamic shape, then we make use of surface modeling. So CATIA is very strong in surface modeling, whereas SolidWorks is very strong in solid modeling, where we create a 3-dimensional model. So 3D modeling is also possible. We have many different options for creating 3D models similar to SolidWorks. CATIA can also do solid modeling, but highly detailed surface modeling is the speciality of CATIA. Digital prototyping, which means we can use CATIA for computer aided manufacturing purposes also, like 3D printing. You can do 3D printing in CATIA using CATIA. After we produce the model, we can directly export this file into a 3D printing machine so that it can perform 3D printing operation, or it can be given to a CNC machine for doing CAM operations, computer aided manufacturing. And you can create and analyze products. So analysis, modeling and analysis is also possible in CATIA. So not just CATIA, SolidWorks also can do some amount of modeling, and some amount of analysis can be done in SolidWorks also. So most of the 3D modeling softwares which are used nowadays, they can do some amount of analysis also. Which industries use CATIA? You can see here mostly aerospace, aviation, automotive and shipbuilding. So wherever aerodynamics is involved, CATIA is used very commonly because it is very it has a very good options in surface modeling. It is very strong in surface modeling. Then again it can be used in solid modeling for consumer goods, plant design, then consumer packaged goods. So other type of industries also use CATIA, but commonly we use it for aerospace, automotive industries, shipbuilding and defense. Then another popularly used three-dimensional modeling software is ProE. So it was earlier known as ProE, and it was in later on the name was changed to Creo Elements. So you might have heard of this name, it is very popular. Creo, also known as Wildfire 5.0. So it is very popularly known as Creo Elements, and again has the same features similar to CATIA and SolidWorks, mainly SolidWorks. Parametric feature based design it provides, and another important feature is again CAD, CAM and CAE, that is designing, manufacturing and analysis also is integrated into a single software. We can do all this in a single software. Capabilities of ProE or Creo: we can do solid modeling, surface modeling is possible, rendering, data interoperability, routed systems design, simulation, tolerance analysis, NC and tooling design. So what is data interoperability? Data interoperability means we can give, or once we create a model in Creo, we can easily export it to other softwares or other analysis or manufacturing softwares or CAM softwares. So CAE, we have other CAE and CAM softwares. Once we create a model in Creo, we can easily export it to CAE and CAM. Actually this option is available in SolidWorks and CATIA also. So data interoperability means the ability to transfer the data between different softwares. Then we have routed systems design, designing the systems, how we can plan the design of systems and different layouts, etc. Routing, scheduling, all those things can be done using Creo. Simulation, tolerance analysis, numerical control and tooling design. So tooling design and other designs for machine tools can also be performed in Creo and ProE. Industries again similar to previous example: automotive, food and beverage industries, industrial manufacturing or plastics. All those industries can use Creo software. You have a number of releases. You can see R means release, and these are the versions that are. Other major software commonly used is Autodesk Inventor. Again, Autodesk Inventor is a software that is manufactured or designed by Autodesk. So Autodesk, this is the logo of Autodesk. So Autodesk actually is a company which has designed or created AutoCAD. This is another product from the Autodesk company that is commonly used for three-dimensional modeling purposes. Autodesk Inventor, founded in 1982. The company is founded in 1982. And we have the AutoCAD, AutoCAD MVP, AutoCAD Civil 3D. All those are the different softwares that are designed or manufactured by Autodesk company. Then Autodesk Inventor features, again most of the features are very similar. Actually, if you learn one modeling software, 3D modeling software, you can see that other modeling softwares will be very easy to learn. If you learn just one, you can easily learn the other softwares because most of the features are common. Most of the options, tools, many of the things are common. So if you learn one software, you can easily learn other similar softwares. Which industries use Inventor? Again, commonly used different industries are given here, similar to previous examples. Then this software was used earlier. Nowadays it is not very popular. I-DEAS, Integrated Design and Engineering Analysis Software. So name itself says there is a design and analysis. So this software is used or was used to perform design and analysis. So it was very popular in the previous years or in olden times, but nowadays it is not very popular in the industry. Developed by Siemens Software, and it was used in automotive industry by Ford and General Motors. So mainly these are the two companies which popularly used I-DEAS, but nowadays there are these companies or other automotive industries make use of popular softwares like CATIA or SolidWorks, SolidEdge, etc. Then AutoCAD, as you already know, it is a very popular used software for two-dimensional, and AutoCAD 3D is also there, where you can create three-dimensional modeling also. And AutoCAD, again, it is manufactured by the Autodesk company. So very popular in especially creating, especially in the civil engineering area, where we can create plans, layouts, blueprints of the plans. Then equipment layouts can be made, model documentation. So we can create a lot of documents and sketches, drawings, etc. using AutoCAD. Features: drawing, drafting. Annotation means you are, if we have a figure, if you have a sketch, then we have lot of information that is given or that we have to mention in that drawing. So such drawings we call it as an engineering drawing. So we mentioned in first class itself what is the difference between an ordinary drawing and an engineering drawing. Engineering drawing will have a lot of details like the dimensions, then the material with which the part is made up of, then what is the tolerance, then what are the different surface roughness values or surface entities. So all these different things which we mention in the drawing, we call it as an annotation. Usually annotations include all these things: surface roughness or the dimensions, the tolerance. All those things are together called as annotations. Then extended workflows. Extended workflows means that we can do or we can use AutoCAD to create objects which are not actually planned before. So we can make a lot of additions. Whenever we do or we design something, if there are more additions or multiple additions to the already existing data, then it is very difficult in the case of other softwares. But in AutoCAD, we can perform that operation also. That is known as extended workflow. Then we have external references. XREFs means external references and block files. All these are options that are available in AutoCAD. External references means if you have to create a model or a sketch, for example, suppose you have to create a sketch of a 3-dimensional or 2-dimensional hexagonal bolt. If you have already created a file of a hexagonal bolt or a nut, we can import this file or this sketch into AutoCAD drawing, and then you can use the features that are present in this drawing. So that is known as external references. External references means you are calling it or you are taking that option from external sources. So this is an external source, an external file which is already there. So you can use this file or information from this file into your drawing. That is known as external references. So dynamic blocks, you can also do 3D meshing, surface and solid modeling. All these options are possible using AutoCAD. Industries, all sorts of industries make use of AutoCAD. Aerospace, aviation, manufacturing, medical, oil and gas, civil structural. MEP means mechanical, electrical, plumbing, a very important area where mechanical engineers are employed. MEP, mechanical, electrical and plumbing. So in construction or in industries or wherever there are buildings, there you have to plan or to model the plumbing and electrical works. So electrical wiring, how the machines are installed, how the electrical wiring should be properly designed, plumbing should be properly designed, then heating, ventilation and air conditioning should be properly designed. So all these designs or design process together, we call it as a MEP process: mechanical, electrical, plumbing. Mechanical works, electrical works and plumbing works, design of all these things are done using MEP. So we have separate softwares, but AutoCAD can also be used for MEP purposes. But most commonly used MEP software is Revit. Revit is the most commonly used software. AutoCAD also has this option. Okay. Then we move on to analysis softwares. ANSYS is the most commonly used analysis software, and ANSYS is actually made by the company ANSYS. It is the name of the company itself, and used to design products and semiconductors, and lot of other analysis can also be performed using ANSYS software, like structural analysis, then fluid flow analysis, heat flow analysis. Lot of other options can also be performed using ANSYS. This is the interface of the ANSYS software, how it looks like. So the ANSYS software interface shows the different parts of the assembly. Here you can see two bevel gears that are meshing with a ring gear, and you have different color combinations that are shown. So in the previous class, one of the classes I mentioned about the color coding. This shows a stress distribution, how the stress is moving or how the stress is propagating. Blue color shows areas where there is least or no stress. It can be stress or strain. And green area shows where the area where there is a little bit amount of stress or strain. Yellow color shows the area where the strain has increased, strain or stress has increased. Orange color, again more stress is present, and red color is a danger zone or the area where maximum stress will be produced. So it can be either stress, or if you are doing any analysis with the heat, it can be heat, or if you are doing any other analysis, fluid flow, it can be any property related to fluid flow. So such color coding will be available in ANSYS or in any analysis software, which gives you an information of which areas you need to design well. So by looking into this, we can understand that this is the area where the concentration of stress or strain or heat, whatever it is more. So you have to give more importance to such areas. Again, another important analysis software is ABAQUS. ABAQUS is actually used for or it is actually a finite element analysis software, and it was used from earlier days itself, and it is a very popular software, but not very much widely used in industry nowadays. So again, meshing and making finite elements is very popular option that is available in ABAQUS. Another most popularly used software is NASTRAN. Nowadays it is known as MSc NASTRAN. MSc is actually the name of the company. that procured NASTRAN or that made NASTRAN. So NASTRAN was actually originated as a finite element analysis program. So finite element analysis program. So NASTRAN was actually originated as a software program or finite element analysis program developed for NASA. So it was specifically made for NASA in 1960s, and later on it was acquired by the German company, that is McNeil Schwendler Corporation, MSC, and they developed the NASTRAN code further. So NASTRAN first of all originated as a small part of a program or a software. A small part was only made just for application in NASA, and it was acquired, or it was taken by this company, and then they developed the code further. So they developed more functionality, they added more functionalities into the software further, and they developed the NASTRAN code. So this NASTRAN code, it is commonly used in a number of analysis softwares. So many softwares, as I told, are available. So analysis softwares, they make use of the certain codes or programs that is written, that is available in NASTRAN, and it is a multidisciplinary structural analysis application. You can do a lot of analysis in that: static, dynamic, thermal analysis, and it can be used in linear and non-linear domains. So linear means the property changes linearly with time. Non-linear means the property can change non-linearly. So definite pattern of change in property is not there. It can change in any way with respect to time. So that is linear and non-linear. So non-linear calculations are very complex calculations or complex analysis. So all those applications can be performed in NASTRAN. It is a very popularly used software, and it is a very direct competitor for the popularly used ANSYS. So ANSYS and NASTRAN are commonly found analysis softwares. So these are the common industrial or the softwares that are used in industry very commonly for the modeling and analysis works. So kindly go through this video